like I was saying, today's topic is also similar to what we covered last week. So this is also churn prediction in a B2B software as a service scenario. So here the company for which the churn modeling was done is basically a software as a service company that offers cloud-based business phone system and call center software. So this is similar to the Skype or the Cisco WebEx or those things that we have, right? So what we used to make calls, and it's not just a normal video conferencing or the internet-based calls, but rather you can also call phones. So like you have the Skype credits, right? That is something that is very similar to that. And so both the offerings are bundled as one, that is the phone system and the call center software. So this call center software is basically a control center kind of thing, which you can use to monitor what calls are being made, how many calls are being made, who's using what, and so on. So both the offerings are bundled as one. This company was established in 2014, and each customer can add several users to their account. So let's say, for example, if we take this service, right, so Perceptive Analytics will be like one customer, and if several of us within Perceptive Analytics are using this particular service, then each of us will be a user. So in this way, each customer or each account can have several users. Okay. And they also offer different types of pricing plans with varying price per user. So the company is organized into 5 business teams. So you have the sales team, then you have the onboarding team, customer success team, support, and marketing. So sales is basically the initial activity that takes place, right? So in order to bring more customers to the company and expand the customer base. Onboarding is essentially where the software is actually given to the customer, and the customers are coached in how to use the software, how to use the service, and so on. Customer success is nothing but ensuring that the service that is being provided is up to the mark and getting their feedback and all those things. Support is basically any issues that happen. So we raise the support tickets, which will then get resolved. And then, of course, there is the marketing team. And they also collect customer feedback using an NPS survey every 3 months from each customer. So NPS, we discussed this in a previous session, the Net Promoter Score. So on a scale of 1 to 10, how likely are you to recommend this product or service to a friend or colleague? So that is what they ask. And based on the score that the customer gives, so if the customer gives a score of 9 or 10, then they are called as promoters. And then if it is 7 or 8, then it is neutral. 6 or below is a detractor, and so on. So this is how they collect their customer feedback. This is just a short overview of the company. Any questions? Okay, we move on. So why did they pick up this churn modeling project? Now, looking at the customer base will give us an idea of why they wanted to do it. So if you look at their entire customer base, they have around 5,000 international customers, and these customers are basically small businesses or startup companies. Okay. And they segment their customers into two types. So any customer who is generating more than $1,000 in monthly recurring revenue, they are called as VIP accounts. Okay. Now the nature of these VIP accounts is such that they represent less than 10% of the overall customer base, but contribute to 50% of the total monthly recurring revenue. And the customer success team, that is basically like the relationship manager or who ensure that the customers or the service is going on fine, right? So this customer success team, almost 70% of their efforts or the manpower of the customer success team is dedicated towards the VIP accounts. Okay. So the remaining accounts, that is almost 90% of the customer base, make up of what we call as the mid-market accounts. Okay. So here there are like many accounts. So here it is only the 10% of the 5,000. All of the remaining are the mid-market accounts. So many accounts, but you have fewer customer service managers, because the 70% of the customer service managers are taking care of the VIP accounts, right? So here you have a lot more accounts, but so few number of managers. So this is where they felt the need to apply this churn model. Okay. So many accounts, so many customers, each with a different kind of a behavior. Okay, so how do you accurately identify those people who are likely to churn? In the VIP account scenario, it is very easy, right? Because the number of customers is less. You have so many service executives taking care of these customers. So, and those customer service executives will know the pulse of the customer, what they are feeling. Just by interaction with the customer alone, they'll be able to figure out. But that is not the case here. Right? This is where, for the mid-market accounts, is where the company thought to apply the churn modeling. Okay, and they just measured the baseline churn metric. So it was like 3%, which is to say, month on month, on an average, 3% of the customers would leave the company to join a competitor company. So let's say, for example, instead of using this company, they might use Skype or something else. So the churn rate was 3%. And though the company was started in 2014, they have this data available only from 2018. That is because they established their data team only in 2018. Only after that they started recording all of their operational data, the customer interaction data, feedback data, and so on. So the data that they have available is only from 2018. Any questions until now? All right, let me move on. So this was the approach that they used for the project. So they used Python for modeling the churn. And within Python, they use the following libraries: NumPy, Pandas, scikit-learn, imbalance. So the typical built-in machine learning libraries that you have in Python, this is what they used. Okay. And how did they define churn? So churn is, basically we say that if the customer is no longer using the product or service, then we call that customer as a churned customer, and this is what they want to predict, right? But how did they actually define churn? So they said if the customer has been inactive for 1 month, he has not used the service, he has not logged in, no incoming calls have been there, or there have been no outgoing calls. So if this is the case for 1 month, then the customer will be called as a churned customer. And the operational data of how many calls they make, for how much time they use the service, and all those things, they are actually collected at a daily level, but for the purpose of modeling, they were aggregated at the monthly level. Okay, and they had, so for all the predictive modeling activities that we are undertaking, we need to have the features, right, or the independent variables which are used to predict the outcome of the target. So those features, they classify into 2 types primarily. So one, what they called as static features, and the other is called as dynamic features. Static features are basically like the customer, country or state or city from which they are, what is the company size, what is the revenue band, how many employees do they have. So these are all what are called as static features. Dynamic features are what change from time to time. Okay, and for how they are creating these dynamic features is they consider customer activity in the past 3 months. Okay, so each dynamic feature this way will have 3 columns, one for each preceding month. So right now we are in April, right? So let's say we consider one feature such as the number of calls made. Okay, so this number of calls made will have like 3 columns. So one for January, one for February, and one for March. That is one for the each preceding month. Okay. So number of calls that the customer has made in each preceding month. That is how they are creating the dynamic feature. Okay, and the reason they are doing this is that they, in their opinion, customers exhibit a certain kind of a behavior during the quarter before they eventually churn. Okay, so according to them, the 3 months is a decent indicator, which is which will sufficiently tell them whether the customer is going to churn in the next month or not. Okay, so the 3-month window they have fixed arbitrarily, and for each of the preceding 3 months, they have calculated the value of the dynamic features. Okay. So these are all the nuances that we should observe whenever we are doing the predictive modeling, because coming up with these features, so all of this is what affects the accuracy of the model, right? And simply it is very easy to just aggregate the data at the month level, and then with whatever features that we have, just build the logistic regression model or whatever, and come up with some outcome, right? But the accuracy might not be that great. Okay, so how do you improve that accuracy? That is where this concept of classifying features as static features and dynamic features. And then you're saying that 1 month's data is not enough. For these features alone, I would need data for the past 3 months and so on, right? So this is what makes the difference between a good model and a great model. Okay? And this is one key takeaway that we should all remember. Any questions on the approach? All right, let me move on. So just a small representation of what the data looks like. So I told you they extracted the data and aggregated it at a monthly level, right? So they have a column that says extract date, which represents for what particular month the data contains. So if they have extracted on 31st of December 2019, then the corresponding row represents the details for this month of December 2019. So similarly here it represents for January 2020 and so on. Okay. So this particular company, they had like 10 users in the essential plan as of December 2019, and the same company had 12 users in the essentials plan in January 2020. They had 20 users in the professional plan in the month of February 2020. So and then they would have all the other features. And this is how they had the dynamic features. So let's say, for example, we are looking at this particular month, right? Month I. Okay? And for the past 3 months, that is I-1, I-2, I-3, these 3 months are what they call as the observation window. Okay? And for these 3 months, they will take the dynamic variables. Okay? And then based on the values of these dynamic variables for the past 3 months, they will assign a value of 1 or 0 in the month I. So that 1 or 0 is what we call as the churn. So if the customer has churned, we put a value of 1. If the customer has not churned, then we put a value of 0. Okay. We basically, when we say 1 or 0, what we mean is the customer is likely to churn during this activation window, that is current month to the next 1 month. So in the upcoming month, if the customer is likely to churn, then we put the 1 or 0 value in the corresponding column for the month I. Okay. So this is how they define the churn and structure the data. Any questions? All right. So what features did they use? They grouped features into 3 categories primarily. So first one is called as customer attributes. So here you have something called as time to close the deal. So I told you, right, their management is made up of 5 teams, out of which the first team is the sales team. So these are the people who go and prospect for customers, talk to customers, pitch the product, and then the sales cycle, if you see, and we have discussed this when we were talking about the B2B attribution modeling and all that. The sales cycle in a B2B scenario is very, very long. Okay, so in a B2C scenario, it can be like, in terms of days or months. Let's say, for example, you're going and purchasing a TV or a mobile phone, right? You might go today, you might inquire what are the price and specifications and all those things. Okay, and let's say tomorrow or day after tomorrow, you will go and make the purchase. So that is a very short sales cycle in a B2C context. But in B2B, a lot of stakeholders are involved, a lot of money is involved. So the typical sales cycle, if you see, spans many months. Okay, so that is why they have felt the need to have this as a variable for the predictive model. How much time did it take from the time when the prospecting started to the time when the deal was closed? How much time did it take? So that is what they consider as the first customer attributes. Okay. And then what is the billing period? When did they subscribe? How much time has elapsed since the subscription? So these are all the customer attributes. And then how do they use the product? So so for each customer, I said, or for each account, we can have many users, right? So how many users do they have? And number of phone numbers per user. So just like you can use Skype to make calls directly to phones, and you can do the same thing with this software as well. And in case customers are using that feature, then how many phone numbers are they using? And the number of inbound and outbound calls. What is the missed call rate? Number of integrations used. So this is like, integration is where you integrate or combine the features of this software with some other software. So let's say, for example, we use Zoom, right? And whenever you schedule a meeting on Zoom, you have an option to add it to the Google Calendar. So that is an integration. Similarly, Zoom has an integration with not only with Gmail, but also with Microsoft Outlook and other platforms as well. So like this product also has certain integrations. And out of all the integrations that are being offered, how many integrations is the customer using? And then customer satisfaction metrics, how was the quality, what was the NPS score that they gave, and so on. Right? So they have the customer service team, they record all the call data, customer feedback data, and everything, right? So from this they have these two features. So once they identified the list of features to be used, these are the steps that were followed. First, they had what we call as the correlation matrix, which is like a heat map kind of thing, and this identifies if any of the independent variables are correlated with each other. So we before embarking on the predictive modeling journey, we will have to eliminate the multi-collinearity. Right? So whatever features are collinear, that is, if there is one independent variable which is collinear or related to another independent variable, then you should not use both of them. You can only use one. Okay? Because if you use both of them, then the model will say that the accuracy is like 99% or 100%. So you should not use both. You should use only one. So you can use this correlation matrix to see what variables are dependent on each other, and then you can eliminate the redundant variables. And then this, I'm sure many of you might be familiar, outlier removal using box plot. And then oversampling. The same thing that we discussed last week, right? So here also, if you see, there is this problem of class imbalance. Out of the 4,000 odd customers that we have, only 3% of them have churned and 97% have not churned, right? So this split of 3% and 97%, you cannot use it directly in a predictive model. So that 3%, based on the observations that we already have, we are increasing that 3% share to, let's say, some 10% or 20% by creating duplicate records. So that is what we call as oversampling. But here in this particular project, what they did was they used one specific oversampling technique called as SMOTE, S-M-O-T-E. So SMOTE stands for synthetic. Synthetic minority oversampling technique. Okay, so synthetic minority oversampling technique basically means you create additional observations which are not there in the existing data. Okay, and you do this by interpolation technique. Okay, so I'm not going to go into detail in all of these techniques right now because we don't have the time, but you can just Google for the information. But what it does is it takes the minority class and then it interpolates between observations of this minority class, and then based on those interpolation, it creates synthetic data points. So that is why it is called a synthetic minority oversampling technique, because it makes the minority class bigger, right? So that is why we call it as oversampling. So they use this particular SMOTE technique. And then for modeling, they tried out two methods. So one was the logistic regression model and the other was the random forest model. And they performed this tenfold cross-validation. So this cross-validation is just, it takes random subsets of the data, it splits that data into the training data and test data, and it does this in 10 iterations so that the model is generic in nature and does not overfit. Okay. So if the model overfits, then for this particular data that we have today, we will have a good accuracy of the predictive model. But tomorrow, if new customers join, the same model will not work out. It will not give the high accuracy. So in order to avoid this problem, we are following this technique of tenfold cross-validation. Okay. And their objective or the evaluation metric for the modeling was to maximize the recall. Okay. So this recall, so just like you have accuracy or precision, right? Recall is another metric by which you evaluate the effectiveness of the machine learning model. Okay. So recall is defined as follows. So out of the totally churned customers, so out of the total customers who have actually churned, how much did the model predict correctly? Okay. So in terms of formula, you would represent it like this. So TP stands for true positive, FN stands for false negative. So this true positive plus false negative is nothing but the total number of customers who have actually churned. Okay. This true positive is nothing but out of the actually churned customers, how many of them have you predicted correctly, as the model predicted correctly. That is the true positive. So that divided by number of correct churn predictions plus number of wrong churn predictions. That is what we call as a false negative. So this is what we call as recall. And so all of the iterations that they did, right, the tenfold cross validation, the logistic regression, random forest. So here they will do the hyperparameter tuning, and all of that was done with the objective of maximizing the recall value. Okay. So based on the two models that they used, these were the results that they obtained. So the logistic regression model gave a recall of 65%. The random forest model gave a recall of 94%. That is, out of the total churn customers that we had, right, the 3% of the churn customers, out of them 94% the model was able to predict correctly. Okay. And so this random forest technique also gives something called as a variable importance plot, as many of you might be knowing. And you can just look at the picture over here. So the top most important variable is the number of users associated with the customer account. So the more the number of users associated with an account, the less likely it is for the customer to churn. Okay. Because there might be a cost involved to switching, right? So today if you're using some software, and tomorrow if you want to discard that software and get another software, then again that entire sales cycle, prospecting for vendors and all those things starts, and it's a huge headache in terms of time, effort, and money, right? So customers who have a large establishment, who where in companies where so many users are already using the service, they are the least likely to churn. So that is why this particular variable comes out as the most important variable. Okay. And then again, if you see, the next important variable is the number of integrations. Again, this is also like integration is also something like adds to the cost of churn, cost of switching from one operator to another, right? The more integrations you have, the more difficult it is going to be for you to churn. And then you have the call quality, a number of phone numbers that they're using, in number of inbound calls, number of outbound calls, and all the other customer engagement metrics. So these are all coming next. But if you see, these metrics are not as important as the first three metrics. And this is like, apart from the call quality, the first two metrics directly talk about directly or reference to the cost of switching from one player to another. So yeah, that is what I had for today.